Similarity. Similar means having the same shape but a different size. Dilations create similar figures. And below we have the symbol for similar. If two figures are similar, then corresponding angles are congruent and corresponding sides are proportional. Proportional means that each pair of corresponding sides are changing by the same scale factor. And to find scale factor, we'll take the part of the new figure divided by the corresponding part of the original figure. So here we have two figures. We have triangle ABC and we have triangle A prime, B prime, C prime. So this symbol tells us that this triangle is similar to this triangle, meaning they're the same shape but a different size. So if these two triangles are similar, let me back up for a second. So what we'll do for each problem is we'll identify an original and a new. Now, it doesn't actually matter what you identify as which, but the reason that we do that is so that we can easily find the scale factor. So if these two triangles are similar, then angle A is congruent to angle A prime, angle B is congruent to angle B prime, and angle C is congruent to angle C prime. So that part is where the angles are congruent. And then we also know that the sides are proportional. So what we are saying is that A prime B prime over AB is equal to B prime C prime over BC, and it should also be equal to A prime C prime over AC. So let's begin to take a look at our examples. All right, so for our first example, we have two triangles. So we want to know, are the two polygons similar? If so, identify the scale factor and write a similarity statement. So in order for these two polygons to be similar, the first thing we need to check is the angles. So are the angles congruent? Now, to help you to do that, just go one by one and look at the different angle arcs. So here we have one angle arc. Well, does this have a partner over here? Think about it like that. Do we have one angle arc over here? Yes. So these two are partners. Okay. What about two angle arcs? They have a partner, and then finally three angle arcs. So what we're saying is that every angle over here is congruent to an angle over here. So the first thing that we check is, are the angles congruent? And yes, the angles are congruent. The next thing that we have to check is to see if the sides are proportional. So the best way to go about doing this is to take a look at the triangle. And I want you to number the sides numerically from least to greatest. So 3 is the smallest, so that would be number 1, then 2, then 3. Again, we just numbered them from least to greatest, 3, 6, 8. And let's do the same thing for this triangle. So this would be 1, 2, and 3. We just numbered them from least to greatest. So what we want to do is figure out which one we're going to make the original figure and which one we're going to make the new figure. And I'm just going to choose this. Again, it does not matter. But in order to get us started and kind of on the same page, I do this. But once you get used to it, it will not matter, what you identify as which. So if we remember to find the scale factor, it is the part of the new figure over the corresponding part of the original figure. So I'm just going to get ready to set up each different number. All right. So the part of the new figure, we're looking at the number ones. The part of the new figure is 1.5 over the part of the original figure is 3. And those are the number ones. The number twos, we have 3 over 6. And then the number threes, we have 4 over 8. Okay? So what we're going to do now is simply divide each of these fractions. So you can use your calculator. So 1.5 divided by 3 gives us 0.5. 3 divided by 6 gives us 0.5. And 4 divided by 8 gives us 0.5. So as you look at these three numbers, you ask yourself, are these the exact same number? And yes, each of these are the same number. So what that means for us is that yes, the sides are proportional. So because the angles are congruent and the sides are proportional, that means yes, these two triangles are similar. So are the two polygons similar? Yes, they're similar. If so, identify the scale factor. Now the scale factor is whatever that common number is. So the scale factor is 0.5. And finally, we have to write a similarity statement. Writing similarity statements is the same as writing congruent statements, except instead of using the congruent symbol, you're going to use the similarity symbol. So let's go ahead and begin. So we see 1 arc, 2 arcs, 3 arcs. So that'll be CBA. So triangle CBA is similar to triangle 1, 2, 3, FED. All right. Let's go ahead and take a look at example 2. Example 2, we have two rectangles here. So as always, the first thing we need to check is the angles. Well, if you remember about a rectangle, all of the angles are 90 degrees. So let me just put my right angle marks because we know that all the angles are 90 degrees. So if all the angles are 90 degrees, then of course they are congruent. So we can check that part off. The angles are congruent. Now we have to check to see if the sides are proportional. So if we remember about a rectangle, opposite sides are congruent. So if that's 12, this is 12, this is 4, this is 6, and this is 16. Now, just like before, we did all three sides. We don't have to do that here because we know that 2 of the sides are the same as the other 2. So I'm simply going to focus on the sides that I was already given. So let's number them numerically. This would be 1, this would be 2, this would be 1, this would be 2. We'll make this original and new. So I got my 1s here, my 2s here. So my 1 for my new is 6 over my 1 for my original, that's 4. And then 16 over 12. So now we just divide. 6 divided by 4 is 1.5. And then 16 divided by 12 is 2.833. Repeating. Now, are these the same number? No, they're not. So what does that tell us? That the sides are not proportional. So the angles are congruent, but the sides are not proportional. So that means that these two rectangles are not similar. So since they're not similar, we don't have a scale factor and we also don't have a similarity statement. Example 3. Again, the first thing that we have to do is check to see that our angles are congruent. So we have 1 arc, 1 arc. So they have a partner, 2, 2, and then 3, 3. Okay, so the angles are congruent. Remember, check that first. Next, we need to check to see that the sides are proportional. So let's begin doing that by numbering from least to greatest. This would be 1, 2, and 3. And this would be 1, 2, and 3. Okay? Now, we'll identify an original and a new. And then we're going to go ahead and form our fractions. So the 1s would be 12 over 16. 2s would be 15 over 20. And the 3s would be 18 over 24. Now that we've done that, we just divide. 12 divided by 16 is 0.75. 15 divided by 20 is 0.75. And then 18 divided by 24 is 0.75. Each of these numbers equals each other. So yes, the sides are proportional. Because the angles are congruent and the sides are proportional, we would say that the two triangles are similar. Our scale factor would be 0.75. And finally, we need to write our similarity statement. So 1, 2, 3, A, B, C. That's triangle ABC is similar to triangle 1, 2, 3, DFE. All right, and finally, our last example, example 4. So the first thing that we check is our angles. We want to make sure that everyone has a partner. So here we have 1 arc, 3 arcs, 3 arcs. And then we have a right angle and a right angle, meaning both of those are 90 degrees. So yes, they are congruent. So we can check that off. The angles are congruent. All right, go ahead and number your sides from least to greatest. 1, 2, 3. And 1, 2, 3. Original, new. Okay, so for the ones, that would be 18 over 45. For the twos, that would be 24 over 60. And for the threes, that would be 30 over 75. So let's begin with the first fraction. 18 divided by 45 equals 0.4. 24 divided by 60, 0.4. And 30 divided by 75, 0.4. So each of those equal each other. So we can say, yes, the sides are proportional. Because the angles are congruent and the sides are proportional, we will say that, yes, the two figures are similar. And our scale factor is that common number, so our scale factor is 0.4. And finally, we just need to write our similarity statement. So triangle, here's 1. And if we already have 1 and 3, that means that we can say that this one is 2, right? So we have 1, 2, 3. LMJ is similar to triangle 1, 2, 3, PNS.